So what is the molecular formula? The molecular formula is a formula that shows the actual number of atoms of each element present in a molecule of the compound. The molecular formula of sodium chloride is NaCl. Okay. Usually, if you have an element with more than one letter, like sodium, Na, you will write the first letter in capital and the second letter in small. Cl, chlorine. So you will write the first letter is capital and the second letter is in small. So this is the molecular formula of sodium chloride. Okay, what can we see here from the molecular formula? We can see what are the atoms in this molecule. We have sodium and chlorine. And how many atoms of each element? So we have one sodium and one chloride, one chlorine. Okay. Another example is MgCl2. This is a molecular formula. What can we see? What information that we can get from this formula? The information that we can get from this formula, the molecular formula shows us the atoms and their actual number. Okay. So here we have magnesium and chloride. We have one atom from magnesium and two atoms from chloride. Al2O3, aluminum oxide. So from this molecular formula, we can know the atoms exist in this compound, which are aluminum and oxygen. And how many atoms of each element? We have two aluminum atoms with three oxygen atoms. So the molecular formula simply give us or show us the actual number of atoms of each element in that molecule in one molecule of that compound. So the molecular formula can represent either the covalent compounds or the ionic compound. Like CO2, when you write a formula, okay? Like this is carbon dioxide. So carbon and oxygen. Okay. So then you will need to write the valency of each atom, of each element. The valency of carbon is 4. And the valency of oxygen is 2. And then we will give the valency of each element to the other. So the valency of oxygen will be given to carbon. And the valency of carbon will be given to the oxygen. And 4 and 2 can be divided by 2. So 1 will be given to carbon, and every 1 carbon will need 2 oxygen. So the final formula is CO2, carbon dioxide. Calcium oxide. So calcium and oxygen. and oxygen. The valency of calcium is 2. You can know the valency very easy from the periodic table. As we said, it is known from the group number. And the valency of oxygen is 2. Okay? The valency of each atom will be crossed to the other atom. So the valency of calcium will be given to oxygen, and the valency of oxygen will be given to calcium, and the result will be calcium 2, oxygen 2. And the 2 can be removed with the other 2. We can divide by 2. So at the end, we know that every one calcium needs only one oxygen, calcium oxide. So just to simplify the ratio. Let's have another example. I will write the example to here in a blank area so you will not get confused. Okay. Aluminium and the oxygen. When they form a molecule. First, the aluminium is trivalent, has 3, its valency is 3. Oxygen is divalent, its valency is 2. What we will do is we will give each valency to the other. So the valency of oxygen of aluminium will be given to oxygen, and the valency of oxygen will be given to the aluminium. And the formula will be Al2O3. And they can't be simplified more. Again, we do that to form a compound. And this is simply how many atoms of the first element needs how many atoms for the second element to form a compound. So H2 elements of aluminum will bind to 3 elements, 3 atoms of oxygen. Let's have uh, iron. Iron, we have iron 2 and iron 3. Iron 2 means Fe plus 2, which means that this iron lose 2 electrons. And the iron 3 is Fe positive 3, which means that this atom can lose 3 electrons. Okay, let's have example for iron 2 and iron 3. Iron 2 oxide. Iron is Fe. Oxide is oxygen. So iron 2, the valency is 2. And the oxygen, the valency is 2, 2. So we will give this valency to oxygen, and the valency of oxygen we will give it to iron, and the result will be Fe2O2. So can be simplified. 2 will go with the other 2 into FeO. So iron 2 oxide is FeO. What about iron 3 oxide? Iron 3 oxide. Iron is Fe, And the oxide is oxygen. Iron 3 means the valency is 3. Oxygen, as usual, its valency is 2. Next, we will cross the valency of each atom to the other. To know the chemical formula, or precisely to know how many atoms of this element is needed for how many atoms of the other element. And the result will be, the result formula will be Fe2O3. And it cannot be simplified because we couldn't divide 2 by 3 or 3 by 2 to get like decimal number or fraction. You couldn't write fraction. Okay? This is simply how we write the molecular formula. So knowing the valency of the element is very, very important. And how we know it is very easy. It is the outer shell electrons, or simply how many electrons can be lost or can be gained by this atom to form an ion. This is the valency. Okay, once we know the valency of every element and the symbol of every element, we will give the valency of element 1 to element 2 and the valency of element 2 to element 1, and we simplify it to reach to the simplest form of that molecule, of that compound. These are examples with the valency or the combining power of each element and whether it forms positive or negative ion, whether it is metal or non-metal, and the resultant compound. So here is the valency of one and the elements that are univalent in metals. If they are metals, so they will form positive ions or cations, and the non-metals will form negative one ion. Okay. And the compound ions that have valency of 1, whether positive or negative, like ammonia, hydroxide, nitrate, hydrogen carbonate, and so on. This is the, the divalence, the valency of combined power 2, metallic ions, and the non-metallic ions. Sorry, the red color come over that accidentally. And the compound ions, which valence are -2, valency 3, and so on. So these are simple ions, metals, non-metals, and same compound ions. This this table is very important, so you can put it in somewhere in front of you all the time. So once you try to write a formula, you can see. If you forget, you can see it. Try to depend on your memory to write the formula of the compound. And if you forget, just look at the table and write it. And also the periodic table is very, very important. This and the periodic table, put it somewhere in front of you or beside you. Okay, this table in your textbook, so you can get it easy from your textbook. And again, practice is very, very important in this chapter. Other examples, we already mentioned this example, but here, these are compound ions or molecular ions, ammonia and sulfate. Ammonia is a positive ion, positive 1, and sulfate is a negative ion, negative 2. Okay? So we will give the number of an ion to the other one, and this is the final formula, NH4 2SO4. So H sulfate ion is HSO4. Sulfate ion needs 2 ammonium ion to form a compound. I will stop here. Next time we'll start with the structure formula. I hope you will practice the molecular formula. Try to get as much as molecular formulas as you can from the slides, from anywhere, and try to write their structure, the molecular structure yourself. It depends on yourself. It's okay to make it wrong. It's okay to make mistakes, because these mistakes will learn you how to do it right next time. And it will learn you when you come to the exam it will be easy. This will be granted question for you. Okay? But again, it needs practice and practice. Practice as much as you can. As much you practice, as how easy you will be able to write chemical formula, and then you will understand chemical equations very easy, and chemistry will be easy even in the next years. Okay, thank you guys, have a nice time, and see you next video. Bye bye.